Tēnā koutou katoa. My name is Nicole Price. I am a technology facilitator at Team Solutions, which is part of the University of Auckland. This screencast is about design elements, and specifically some key messages related to the Level 1 Design Element Standard 91053, otherwise known as 1.10. This particular standard falls within the generic technology domain. The standard asks students to demonstrate understanding of design elements. This is part of a series that we as technology facilitators are doing to cover the externally assessed technology standards. Others that we have done to date cover 1.5, 1.6 and 3.6. They are available along with other webcasts and PLD resources on our technology wikis at these addresses. This screencast is being done as part of the Secondary Student Achievement PLD contract, which is funded by the Ministry of Education. Achievement Standard 91053, otherwise known as 1.10, is a specialist standard that is not directly linked to the 8 achievement objectives within the New Zealand curriculum. However, it is seen to have fundamental links to the process undertaken within a robust technological project, and is most closely aligned with elements from tech modelling and tech outcomes. Please note that specialist standards are only available from Level 6 to Level 8. The starting point when understanding the requirements of an achievement standard is to unpack what the standard says. I would start by asking yourself these questions. What is the learning objective at curriculum level 6? What do the indicators of progression say? And what other curriculum guidance is available? Design and technology refers to the practice undertaken to create a technological outcome, as well as to the description of the physical and functional nature of that outcome. Students come to understand design and technology as both a verb, to design, and a noun, design. Examples are given throughout TKI in regards to what the teaching and learning for this standard may look like across the different disciplines of technology. For more specific information about design elements at curriculum level 6, go to the Teaching and Learning Guide for Technology, available at this TKI web address. Then navigate to the Design and Technology section for curriculum level 6. Let's start by looking at the standard requirements. What sets technological practice apart is its purposeful and productive nature. Outcomes are arrived at through a deliberate process of design, decision-making, production, and manufacturing, rather than by evolution as in the natural world or by chance. It is a fundamental component of the assessment for this standard that students are able to show their own thinking, reasoning, and decision-making throughout their work. So what are the design elements? I've just stated that students are required to reflect and discuss on the elements of design within their own practice. They cannot do this without a clear understanding of the definition of design elements in relation to the broader context of the design field. Explanatory Note 4 from the Achievement Standard goes some way to list potential elements that could be used. Here is a link to a literacy resource that unpacks some of the elements and describes their uses within the context of design. The last web address is a link to my predecessor Leslie Pearce's 2012 workshop on this standard. Her resources can also be accessed through our Technology Wiki. Remember, there is more to design elements than just consistency, repetition, alignment, and proximity. A potential barrier to student success has been teachers focusing their students on these four in particular. The message is to encourage students to explore a range of design elements. Explanatory Note 4 suggests line, balance, shape, colour, symmetry, strength, contrast, durability, and alignment are a sound starting point, but by no means are they a definitive list. Further feedback from the panel leaders' reports from 2014's externals suggests that there are four main barriers to students achieving success within this standard. Number 1. Design elements are not discussed through the lens of subjective and objective. 2. Student research is not applied. 3. There is a lack of personal voice and opinion. 4. Scaffolding can be limiting to student success. Let's unpack each of these in more detail and discuss the connotations. Subjective versus objective. Students can struggle to clearly articulate the differences between subjective and objective views. The definition of subjective is based on personal opinions, interpretations, points of view, emotions, and judgment. Objective information is analysis or fact-based, measurable and observable. There is room for both of these views in design. For the purposes of this standard, it is in the student's best interest to be able to discuss and compare aspects of them both. This leads to point 2, in that student research is often not applied. Panel leader reports state students did not provide images, screen dumps, or printouts of the outcome they were describing, or to a lesser extent provided black and white images when colour was being discussed, or provided images that did not show link to their own practice. Comment was also made that students described poorly designed outcomes, which did not give them enough scope to demonstrate understanding of design elements. Students that tended to gain not achieved grades limited their critique to identifying the existence of an element within a design, rather than how the design elements were applied, and did not comment on the impact, both positive and negative, that the application of design elements had on the outcome. The third point was that research was not aligned with own tech practice. Candidates who critiqued the application of the design elements within existing products and outcomes relevant to their own technological practice, and then clearly applied this knowledge within the development and evaluation of their own outcomes, continued to be more successful and were significantly more likely to gain merit and excellence grades. The requirement to describe the quality of an outcome is clearly stated within Explanatory Note 2. In addition, some candidates' achievement was restricted due to different products being used to identify and describe the application of each design element. These candidates were unlikely to advance beyond an achieved grade due to a lack of explanation and the use of a less robust compare and contrast model. The last point, point 4, was a lack of personal voice and opinion. The panel leader report suggested there was an inability to identify candidate voice and the information not being contextualized nor used to inform candidate opinion within their own technological practice. This restricted candidates for accessing higher grades. Leading on from the previous slides, these submissions were often template-based with limited scope for divergent thought and were regularly repetitive. Please note that while templates are a good way to brainstorm and order thoughts, they should not be a definitive structure for collecting evidence, as students often write to fill the boxes and tend not to link to own experiences. Candidates who utilize templates in teacher-led activities often produced repetitive text, and many duplicated the same content and level of evidence for different products. In addition, it was often difficult to differentiate between information provided by the teacher, downloaded, group work, and that produced by individual candidates. For this reason, the use of student voice shows a greater link to authenticity. Another thing to consider is the hierarchy of evidence. Evidence should increase in complexity, depth, and following the literacy step-ups as the report is developed. What do I mean by this? For example, the wording in the Achievement Standard states that for achieved, the students must demonstrate understanding. They do this through describing certain elements. For merit, students must demonstrate in-depth knowledge by explaining the elements. And for excellence, students must demonstrate comprehensive knowledge, and they do this through discussing the elements. As far as suggestions go towards helping your students gain success, I would recommend considering the following. Setting the context around student interest and ability. Enable personalized learning in order to promote individual student voice. Use a wide range of evidence to support diverse learning styles, student collaboration, and evidence collection. Consider literacy to support the standard. A compare and contrast strategy is a good example. It is a good way to get students thinking beyond their opinions on the elements. Asking the question, how is this the same or different from the last example we looked at? And getting the students to elaborate on the because sitting behind their perception is getting them to explain and discuss, therefore extending initial answers to merit and excellence. Unless otherwise indicated, all the images used as examples of student work are from the 2014 exemplars for Achievement Standard 91053. If you wish to clarify anything that was covered within this presentation, please contact the facilitator in your region, and thank you.